All right, in this video, 5.7, we're going to be looking at normal distribution calculations. And this is very similar to what we did in 5.6b, but now we're going to put it in context of a real problem. All right, so you need to write these steps down. These are what I'm expecting of you anytime you do a normal probability problem, normal distribution problem. First thing is you're going to draw a normal distribution with the horizontal axis labeled and scaled using the mean and standard deviation, the boundary values clearly identified, and the area of the interest shaded. Number two, you got to perform the calculations. Now you're just going to use the calculator, use the technology, to find the desired probability, which is just the area, without standardizing, meaning you're not going to mess with z-scores. But be sure to answer the question that was asked. And number three, interpret the answer in context. All right, so this slide is giving you the context for the problems we're going to model for you. It says, let us examine the continuous random variable x, which is the ITBS grade equivalent vocabulary score for a randomly selected 7th grade student in Gary, Indiana. So the mean, it says it's approximately normal with a mean of 6.84 and a standard deviation of 1.55. Now, remember what these scores mean. Like 6.84 means they're at the 6th grade level, 6th grade and 8 months into the 6th grade level. That 0.8 means 8 months into it. So that's the context for the following problems, so you know what I'm talking about here. All right, example 1. X equals the ITPS grade equivalent vocabulary score for a randomly selected 7th grade student in Gary, Indiana. Done that. The distribution is approximately normal with mu equals 6.84 and sigma equals 1.55. So I draw my curve and I put mu in the middle. And standard deviation is 1.55. That's great. Okay, so then it says, what's the probability that x is less than 4? Well, 4 would be to the right of 6, right, on the number line. So I want less than 4, so I'm going to go lower. All right, so these two tails go to two extremes. This tail goes to -1 e to the 99th, and the positive end of it goes to +1 e to the 99th. So if it asks you your low bound and high bound, those are what you're going to use, similar to what we did in our previous lesson. But now we're putting everything in context, so mu and sigma will look a little different. So just like before, we're going to go to normal CDF, and it's going to ask me my low bound, my upper bound, it's going to ask me mu, and it's going to ask me sigma. Everything's in context of this problem. So if I look at my shaded region, what's the low end? Well, the low end is -1 e to the 99. That's like negative millions. Upper bound is all the way up at 4. Mu is 6.84. And sigma is 1.55. And I got that straight from the problem. Okay? So putting this in the calculator, second bars, normal CDF is number 2. So in my lower, I want -1, so I put -1, and E is right above the decimal. It's a little blue thing. So you have to hit second decimal, 99. Your upper bound is 4, and then my mu is 6.84. Standard deviation is 1.55. Hit enter, interpose. There it is, 0.0334. Okay, so now that's the drawing part. This was step 1. Step 2 is using my technology. Step 3 is interpreting this in context. So we would say there is and then we make this a percent, move the decimal machine, a 3.34% chance. And then you go back to the stem of the problem. Okay, what is it? It's a randomly selected 7th grade student in Gary, Indiana that is has a score of less than 4. So there's a 3.34% chance that a randomly selected, I would say 7th grader in Gary, Indiana has an ITBS score less than 4. Okay, I know it's a sentence. I know you have to read to get the context, but you can do it. All right, so let's try another one. All right, same deal, ITBS guy with the same mean, same standard deviation, but it's asking us a different probability. They're asking what's the probability that the score is between a 4 and a 7.5. This is a between problem, all right? So we draw our drawing. It has to be perfect. 6.84 is my mean. And then I label my boundaries, okay? 4 is less than 6, so it goes here. 7.5 is over here somewhere. And I want the between area. I want just this area in here. Okay? So I go normal, CDF, and the order in which you put all this information in your calculator is always the same. It's lower, upper, mu, and sigma. So I will let you put it in shorthand if you want to. Okay? So lower in this case is 4, upper is 7.5, mu is 6.84, and then sigma is 1.55. And I'm totally okay if you want to write it like this. Norm CDF 4, 7.5, 6.84, 1.55. That's okay with me. All right. Now, when I run these numbers, my low bound has changed. It's now 4. Upper bound is 7.5. Mean is the same. Standard deviation is the same. And there's my probability. 0.631. 0.631. Now, that's step 2. Remember, 3-step process. 1 is the drawing, 2 is the normal CDF statement, and then 3 is interpreting in context. You can say there is a 63.1% chance that a randomly selected 7th grader from Gary, Indiana scored between a 4 and 7.5. Okay? Gotta have the sentence fully in context. All right? Number 3. Same idea, same test score thing, same mu, right here, same sigma, that hasn't changed. Now, what has changed is the type of problem. This is a percentile problem, all right? So what it does is basically reverse of what we've been doing. We have the area, and we want to know what is the score that cut that area off. What's the boundary line, basically, that cut it off? So they're kind of the reverse of what we've been doing. So these are inverse normal problems. That's why the function in your calculator is called inverse norm. It's under the same place you found normal CDF. So you would go to second vars, and you see inverse norm right there. It's number 3. Okay? And if you hit number 3, notice it asks for 3 things. It asks for area, mu, and sigma. All right? Let's get my calculator over for a second. So look at this problem. What test score replaced a Gary 7th grader at the 90th percentile of the distribution? Now, 90th percentile means that the area under the curve is 90%. So this part right here is 90%. This little part over here is 10, right? Because it adds up to 100. Now, percentile, when they give you a percentile, it's always the area to the left. Okay? Always the area to the left if it's a percentile problem. Now, sometimes there's some tricky problems, and I'll try to give you a heads up on those, but generally it's the area to the left, and the calculator can only read the area to the left. All right? So in my calculator, I'm going to have to put in area of 0.09, mu, which was given in the problem, 6.84, and sigma 1.55. So what you would show me in your work was number 1, the drawing, right, with mu labeled and the areas shaded. Number 2, you would show me that you used inverse norm and the 3 pieces of information, the area, the mu, and the 1.55 sigma. Okay, so this is step 2. And what do I get when I do that? Let's see. I get 0.9 for area, 6.34, and 1.55. Hit paste, bam, there it is. So that's giving me the test score that would make a student in the 90th percentile. So if they get an 8.3 or higher, they're better than 90% of the population. That's what they're saying. So 8.32 is what my answer is going to be. So it's 8.32. All right, now number 3, put it in context. Always put it in context. You would say a test score of 8.32 would place a Gary, you could say a Gary 7th grader at, not in, but at the 90th percentile. Okay, so that models for you the 3 type of problems you'll do when you do normal calculations. We'll talk about this in class also, but it's really not too bad. You draw your pictures, you see what's going on, and you plug in your information. All right, good luck. We'll see you in class.